Hi Helen, we would like to do presentation today. Very happy today. And this is my supervisor Dr. Yang, and this is my another team member Yang Wu, and I am Grace Hao Wang. We have another member called Xie Chen, and let's do it. So our topic today is about how to implement image recognition detections in the age calculating. And I'm Hao Wang. We are the group 49 we already introduced. And I will introduce you the background first. Actually, with the development of the internet and the mobile internet in the recent years, and the popularity of the electronic devices such as mobile phone and computers, iPad, something already brought us a lot of convenience, right? And the social media become more and more popular. People can chatting, sending photos, and have a video chat everything, like Instagram, WeChat, Facebook. They already generated hundreds of millions of photos every day. Like I always chatting with my mom, I use the videos, and sometimes I sending photos to my parents. At present, electronic imaging become more and more important in our daily life, and the use of the intelligent recognition technology in this image processing become more and more important and make people's life is more convenient. And the rise of the technologies already attach a lot of people's attention and even big companies' attention. So our project in this part will have a really, really good future. In the future, will be very useful. So for now, we have to make some idea. What is image recognition? Image recognition is the use of artificial intelligence technology to enable the computer to recognize information from the image or just the images. And there is four steps to do the image recognition. The first is image collection. So you collect the image from everywhere, like the maybe photos or cameras, everything. And then second is image pre-processing. And actually, the image pre-processing is very, very important because this could simplify the information recovery data in the image and also restore the real information to enhance the detectability of the information. And the third one, the extracted image features. This one could used to describe the main information of the image, and then you got the information recognition. As we all know, actually in our world, they have a lot method to study for the image recognition. This four is the most popular one and most useful one, easy to use. Choose a suitable image recognition method could improve the quality of the image recognition a lot. So very, very useful. The first one is a classification method. They are generally divided into the color feature. So this method is more for the color. Second one is object detection. This one consists of two parts. One is to determine whether this object belonging to the particular class appears in the figure, and the second is to locate the object used to representations in the bounding boxes of the object. So the boundary in this method is important. It's a key word. The third one, we heard the name labeling is about the label. This method requires each pixel in the graph to be labeled as some like an object category. And actually different instances of the same object in this method so don't need to be split separately. So this one is easy to use. And the last one, they combine two different methods together. And next part, we will welcome our lovely partner to introduce you some details of the processing of the operations and our outcome of the whole project.
Okay, thank you for Grace. My name is Yang Wu and my student number is 12182919. For my part, I will briefly introduce the op- operational process of our project. And there are uh, 8 parts. That's what I want to talk about. So first of all, uh, uh, let me to introduce operational environment. Uh, our system is Linux and Windows, um, and we are using a Python 3 because it's compared to Python 2. Python 3 addresses and fixes drawbacks of design. And actually, Python has many models such as TensorFlow, Keras, NumPy, Matplotlib, and so on. TensorFlow and Keras are both deep learning frameworks. You can think of Keras as an API for TensorFlow. NumPy is related to processing numbers. Matplotlib for visualization. You know, due to the limitation of time, I won't talk more about this. I give some details on my report. So the next is about data collection. Simply speaking, the main part of the image recognition project is to train the model through a large number of samples. So we have to collect a lot of image data, and you know the quality of the data set will affect the quality of the later training results. So I think we must select a better quality images at the beginning. Uh, yeah, you can see the picture. The first picture is clear, and the second picture is blurry. So I think these two images can distinguish between good quality and a bad photo. Yeah. I will talk about the filter data. When we finish collecting the good quality pictures, I use the PS, CAD, some graphics software like this to sketch the portrait coordinates. This work takes a long time. Actually, I think maybe I need to 1 week, yeah, to finish it. Then combine the Python to write some code to change this photo uh, to this photo. Yeah, and here I will demonstrate it. Okay. Here I store the coordinate information as a JSON file. This format file has the advantages of easy reading and writing, easy machine analysis and generation, and effectively improving network transmission. So, okay, the next is about data set uh, classification. I divided into this data into 3 parts. The training set is used to train the model. The raw data is used to optimize the model, and the test is used to determine whether the model is successful. Uh, and the training model uses a large number of training sets, so it requires a lot of computing resources. And this uh, hardware is very demanding, and it will consume a lot of time. So, so For our project, we implemented the transfer to the training data to the .npy files are coded with the non-transformatory format, which reduces the size of the data set and speeds up training. Okay, the next is create a model. The project we choose is Tiramisu model. In Chinese means tiramisu. And before choosing this model, we actually considered three models, including tiramisu, FCN, UNet. After deeper research, we have founded FCN. Then we did some tests for comparing the two models, the tiramisu model and the UNet. Finally, the model of tiramisu performed better. Yeah, and okay, yeah, you can look at okay, okay. The next is a training model. This the training model can be simplified understood as you putting a large number of image samples into the model, making the model remember what's the path tree. I think it's like a human brain, and then automatically retaining the portrait and removing other unrelated factors. In this project, we use the default parameters to train the model, which is standard across EGPAT loss and RNSP job. Optimization strategy, learning rate eyesight 0.001. Uh, and in order to save the model uh, periodically after each improvement, we set the approach to 120 images. The project only trains two categories of characters and the background. Later results show that only two categories were trained and the expected goals were already achieved. In addition, in order to speed up the model reading data process, compared uh, combined with Python, we created a text document containing only the path, as the picture shows. Yeah. Uh, the advantages of this is that one want to read the when running the function of load data, you don't need to read the entire hard disk. You only need to read the path in the file, which reduces the resources consuming and saves time. Yeah, and this is the code. I can't demonstrate here because it takes a lot of time to train the model each time, so I can only put a short video. This video records the situation when I was training the model. Okay, then the next is testing model. I think the earliest way I want to test a model is through version. Look at the picture below. The person on the picture is me, and if the model output behaves like this, I think this model is good for this subject, for this project. Yeah. And the other test method is based on the evaluation system of target detection. The most important uh, parameter is IOU, which can be shown below. Yeah, you can look at this one. Uh, MCC means success rate. Look at the numbers. This number is almost uh, 97%, close to 100%. So I think it can be proved that the model is good. Yes, and the next is working future. Our model encountered some problem that if the image including an animal or something like a bicycle, the performance is not perfect. This is the part I need to dig better. Okay, now I'm going to do a easy demo. Hello, see you again. And on the hello, see you again. On this part, I will see you again. Hello, see you again. And on this part, I will show my project. Hello. Yeah. Hello, Professor Liu. And on this part, I will demonstrate my project. So I think we have finished. My demonstration and presentation are finished. In fact, I have a lot of details to explain and want to display. But you know the time problems, yeah. So if you have any questions, please email me. I'm willing to explain the details for you. Thank you.
Hello everyone, this is Chen Xie, student ID 12694547. I will analyze the methodology we deployed in this project. In the initial step, we need to figure out whether the research will be qualitative or quantitative. The qualitative aims to determine that it depends understanding of a human behavior and also figure out the reasons. The variables in qualitative research are usually in linguistic terms such as poor, good, or excellent. But when it comes to quantitative, the research are using statistical, mathematical, or computational techniques. The variables are usually in numerical values such as 0 for poor, 2 for good, or 4 for excellent. The conclusion of this type of research will be made on the numbers. And also, there are no cause effect relationship can be proved using this type of methods. So because the prototype where we've produced or formed usually are just usually evaluated by the accuracy. So this accuracy or the ratio, like how many percent accurate. So this numerical values will prove that this research will be quantitative. And comes to the research methodology, according to the various methodology I found from the references, I think experimental research will be mostly suits the type of methods we of this project, because this one is prototype based. They are quantitative, and also significant feature of this is the researcher will need to isolate and control all the relevant conditions. That this condition determines the events for investigated, and also why the researchers do that, because they want to observe the effects when those conditions were manipulated or changed. In this project, I found once we formed the prototype, it was formed based on the training data sets of pictures, and then tested with another set of pictures. We name it testing. So basically, the condition was changed, and also the other variables were changed by Yang when he was building up the prototype. So we try to observe how the results will be changing based on the changing the variables. Those attributes prove that experimental research should be the methodology of this project. And comes to why do we conduct this research, we need to identify the rationale for research. There were two type of significance. The first one is the research one, or technical aspect. We want to first identify the image from the pictures, the image objects from the photos, and also want to evaluate if the image recognition AI could over eligible for its function as we expected, and also we want to evaluate if that is potential to deploy in this recognition AI in edge computing. For social significance, we expect that using the image recognition function, those functions could be deployed on other edge computing devices like a phone, smartphones, surveillance camera, or like computers on the vehicles. So with this function, the users could identify the items or the people. That is what we expect from doing the project. Now here is how we manage to. That is how the methodology goes.
Well, it's my turn again. I will introduce you the last part, conclusion of our project and the significance of the whole project here. Actually, with the development of deep learning and the increasing demand in the field of the image recognition, the future development of this technology, will become more and more useful and more intelligent. So there are four tendencies and also some problems for the now. In the futures, there are the tendency. The first is the level of the model is increasing, and the structure is become more and more complex. Actually, the deep learning needs to model the target features of the image layer by layer. So there are a huge amount of layers. If the depth of the network model is not enough, the required computing unit will increase exponentially. So it's a lot. As the complexity of image recognition increase, the image actually needs to be divided into more and more, many species or many part. And there are many local areas which require constant depending of the model hierarchy. So learn through multiple levels of the features. And the second we can see here is the scale of the training data is increasingly rapidly. Because as the deep learning models become more and more complex and requires more and more features, of course, the requires a large amount of the training data to improve the accuracy of the classification or prediction. So for now, the training data of the deep learning are generally like hundreds of thousands, millions of levels, right? But for the Google, Facebook, Microsoft, and Baidu, this kind of the big technology companies, the training data is tens or even hundreds of millions of levels. So just imagine we because for for now the existing imaging data still cannot meet the growing training needs. So you can just imagine how it works. It's really hard. Third one is the recognition efficiency and the detection accuracy of the model are getting higher and higher. Of course, getting higher and higher. With the continuous development of the deep learning models, the efficiency and accuracy of image recognition is already have been greatly improved. But the model recognition efficiency and detection accuracy are constantly improving, but still have a long way to go. Actually, we can see there's a difference now and the future. Nowadays, computing software and hardware are continuously improved a lot and developing as well. Nowadays, the research more focused on the speed of the computer intelligence image recognition. And the information processing capability of the computers have been further improved. And this aspect of the compressions has been able to on the verge of success actually. And the focus on the future is different. The focus on the future research is more highlight the individualized needs in the of intelligent image recognition. So the individualized needs, this is the keywords. The processing of the image should be gradually tilted from 2D images to 3D images, even multiple dimensions. So directions are also developed. For example, there are different works can use for of the image recognitions like the in the business field like the management of employee attendance and even the security part even the different works they can use our applications which relate to the image recognitions. So over the years, with the deepening of the research in the field of the deep learning, actually the research progress of image recognition technology already have been greatly promoted, and the research and applications of the image recognition technology also have advanced rapidly. But the world majors company like the huge companies, they pay more attention for this part, and also they want to get a really good outcome from this part. So we can see the image recognitions, even they have a long way to go, but they already got a big success. And more and more people's companies, everyone will pay more attention on these majors. Thanks for your attention. This is our presentation. We are group 49.